All right, period and frequency of a mass spring system. They show you how they derived a couple of equations here. If we say that if the kinetic energy, set that equal to EPE. Kinetic energy is 1/2 mv squared, and EP is 1/2 kx squared. We can multiply both sides by 2. By doing that, 2 times 1/2, that disappears. So we're left with mv squared equals kx squared. And we know that velocity in circular motion is 2 pi r over t. So we can put that in for velocity, but remember the velocity gets squared, so we have to keep that squared. At this point in time, we're going to say, okay, the r, which is the radius, is going to be equal to the displacement, which is x. So we can substitute x in for r and get 2 pi squared, and r is squared, so that means x is squared, right? And we can divide that by kx squared, which goes in the bottom, and t, which was squared, will now get multiplied on both sides so that we have t squared over here. The x squareds are going to cancel out, and we're left with taking the square root of both sides. We're left with the square root of m over k times 2 pi, which is the period of a spring mass. And how I tell students, not that you have to memorize this or not that you have to know how to derive it, like on this side. What you need, a good way that I recall this is period equals 2 pi of the square root of Michael Kors. And we know that frequency is the inverse of period, so frequency is 1 over 2 pi square root of Kors Michael. So that's our big two equations. We have a problem. What is the period? Let's do our givens, unknown, and periods in seconds of a mass spring system if the mass is 4 kilograms and the spring constant, that's K, remember, is 64 Newton meters. So we have our equation, period equals 2 pi square root Michael Kors. We can plug in our M, our K, take the square root and multiply by 2 pi, and you get 1.57 seconds. Whoa, let's go back here. Let's go back. So we get 1.5, so period equals 1.57 seconds. What's the frequency of the mass spring system from the previous slide? So we can use the equation frequency equals 1 over 2 pi square root of Kors Michael. We can plug in our values there and multiply it out, which is a little bit more work, and we're going to get 0.64 hertz. Interesting though, there is an easier way of doing this. Here's a little trick for you. We know that the period is equal to 1.57, and we know that frequency is equal to 1 over the period, so we could just do 1 over 1.57, and let's see, 1 divided by 1.57, and I'm getting 0.64 hertz. So it looks like there's an easier way of solving that particular problem.